are here at Doug Martin. It's a 250 cow robot barn. He beds with sand and has a flush system. So he originally started out with this Bauer pump. With this design, it does not like sand. So after a bit, I got a phone call one day that said, hey, their pump isn't working. Its splines wore out in the shaft. Wondered if we could stick a Cornell pump in. Stuck the Cornell pump in, started having trouble with it. So he originally had this Bauer pump. It was a 10 horsepower single phase, which is 1800 RPM. And when they asked about sticking a Cornell self-priming pump in, one of the things it said was, we're gonna be right on the edge of head pressure, like the total amount of pressure it can pump without spinning faster. Ideally, you'd be running at 2000 to 2200 RPM to get more pressure. Here's our flush tower. We got our barn. This is a 2-aisle barn. You got a little bit coming out the end and dropping down into our pit. Here's our pump. There's two key things that you want to look at. One is from your pump to your overflow. How many feet is it? Second key point is from the pump to the bottom of the pit. So there's a limit on how far you can lift or suction, how deep your pit may be below your pump. It's a 16-foot deep pit. So they put the pump down about 8 feet. That way you don't have more than 8 feet of lift. And that was simply in a box next to the pit. Then we come to the top of the flush tower. Reason it's very important to get to your overflow is because, being that it was a replacement pump and it was limited to 1800 RPM because we're reusing the existing motor, that flush tower, it would only fill to about here, and the sensor was trying to fill it to there. So the pump would pump it, and then it would never get full. So it would just sit here and it'd be running, and the pump would get hot. And having an overheated pump is a bad thing because it causes other problems. Ideally, you have a VFD on your pump motor because at 2200 RPM, we can get a lot more feet of head so that it can come out the overflow. That way, if your float or your sensor goes bad and it says that your flush tower is empty when really it's full, you want it to be able to come out the overflow. Otherwise, your pump just sits there and runs and runs and runs, and you don't know it. The other thing is the amount of feet from the center of the pump to the bottom of the pit. That is important because there's a limit to how much lift you can have. Technically, you're using atmospheric pressure and you make a vacuum with your pump. Your pump does not suction. It's just creating low pressure. The key takeaway on a flush system design is know how many feet ahead you want to lift. Also know how many gallons per minute you need to fill that for how much flushing you're doing. And then your depth of your pit. So there at Doug Martin, I'm saying 50 feet. Really, I think it's more like we're going to cross that out. We're going to say 70 feet. So we got 70 feet from there to there. Down here we have 8 feet. And sorry, I'm looking at it crossways, so right crossways. So we got 70 feet, and we're wanting to get about 300 gallon. So we want about 300 gallon a minute coming through. We got a 10 horsepower motor. We got 1800 RPM. We got 70 feet ahead and 300 gallon a minute. So we're gonna look at the pump curve for this pump. This is a 3STX pump, same thing that Doug Martin's using. And we'll look at the pump curve and see if our numbers hold out, what that shows on the pump curve. So there at Doug Martin, we have about 70 feet of total head or lift that we need to get to. So we got an 1800 RPM motor. So right here on this chart, you see your line for 1800 RPM. Over here on this side is your total, your feet of head. And then across the bottom, this is your gallon per minute. So we take our 300 gallon a minute and we come up here to 1800 RPM and we're right in there. If we go across, we're almost at 70, probably about 68 feet ahead. So that is the point. And then the next thing is, are we actually running 1800 or is it a 1740? That all makes a difference. If your flow gets down to 100 gallon a minute, now we're close to the 80, total of 80 feet. But you want to have a minimum of at least 10% of room. Like if the pump starts to wear or gets a little thick, something like that, it's going to pump harder. And so you need extra. And that's where ideally you'd have a VFD that you could speed it up. Now the next thing we're going to run into is over here's your horsepower. So 10 horsepower, we're crossing the line right at 300 gallon a minute. If we want to speed it up, if we want to go to 1900 RPM, we're going to have to be back to that 200, 180 gallon a minute when that pressure gets up there. Otherwise, we'll overload our pump. That's where
on a new installation, I'm going to put a 15 horsepower motor on there with VFD so that we can run that 300 gallon a minute. We can take that up to 2,000, 2,100 RPM. And at that point, we have almost 90 feet ahead. So we have an extra 20 feet that we can keep filling. That way your pump will never stop and just sit there and heat up. If you're designing a flush system, you want to look at one of these charts. Down here is the model number, and always give yourself at least 10% more. So if you look on here and you say that, hey, I'm going to need 80 feet, like go to at least 90. Cornell would say if it calls for a 10 horse motor, go to the next size bigger, go to 15. The reason being is if it takes just a little bit more than you think, because if your flow rate, so let's say we get out here to, you design this and you're assuming 300 gallon a minute. Well, if it actually can push 350 because there's less restriction in your line than you thought, it's going to push faster, but that takes more horsepower. So if it's trying to do 350 gallon a minute, all of a sudden your electric motor will overload and get hot. A diesel engine will just slow down because it's a centrifugal pump. So on a diesel engine, you can't overload it because the RPMs will just start dropping back until it's holding at whatever horsepower it can make. On an electric motor, you're trying to maintain an RPM. So when you're doing electric motor, make sure your motor is plenty big, because otherwise you'll run into issues. One more thing to show you on this up here across the top is efficiency. At 300 gallons a minute, you're right in that sweet spot of efficiency, as you can see. So this, at its best efficiency, is 56%. These pumps are not a high efficiency pump. A dragline pump, we're going to be 65 to 70%. So what that means is that half of your energy, well, 40%, 45% of your energy is getting turned into heat. The rest of it's pumping the liquid.
So what I did to get around that, I took this plug out and put a short piece of pipe fitting on here and a temperature probe in the end, so that when this gets hot, this is our outlet port and the heat will show up here first. And that did happen. He had here about a week ago, he called me, said his pump lost prime. The reason it lost prime was because they were hauling manure. They drew the pit down too far, and so they have multi-stage. There's multiple pits, and this thing's sucking out of the stage 2 pit. Well, the stage 2 pit gets empty because there's not much there, because it's all circulating back into stage 1. So it sucked air, lost its prime. So it's sitting there slurping air in the end, and it got hot. Our temperature thing turned the pump off, and the light went on saying that there's an over temp. So they figured that out. So the problem with a self-priming pump, they work best is if this is vented to atmosphere. The problem is it's not. It's going through a line into your flush tower. So you got a lot of back pressure. And once you put air in here, and now you try to get it going again, that air needs somewhere to escape. So if you lose prime, you gotta release all your pressure off your outlet side of your pump. Otherwise, it just won't go. So this is a self-priming pump. But just because it's self-priming does not mean that it can self-prime when you have head pressure. If your line going to your flush tower is full, you'll never prime again, because it's pushing backwards. To prime these, you got to vent this to atmosphere. Like, it's got to be vented, either drain everything out so that you have air going clear up to your tower so that it can start filling the line and get going, or don't run it out of manure. I'm Eric Hoover. We build dragline equipment. We've built some flush valves in the past. However, we're busy enough with the dragline equipment that we only sell the pumps. If you're looking for a pump for a flush system, we'd be happy to talk to you. If you want to build your own flush valves, I'd be happy to share my design with you, because we've built them in the past. However, it's not our core product, and we're trying to stay focused on the dragline equipment. If that is of interest to you, I'd be happy to talk to you. You can call me on my cell phone, 610-468-9666.